Well, at this point, we begin Chapter 12, and the title is Logical Elements and Operations on Logical Elements. So far, we have looked at three data structures, and those data structures are the one-dimensional vectors, the two-dimensional matrices, and the three or more dimensional arrays. We also have looked at a number of data types, and the first data type that we encountered was numeric. And with a numeric data type, you are looking at basically numerical values. They might be floating point, they might be displayed in scientific notation, but you're looking at numbers in there. Then we went forward to complex numbers as our second possible data type. And just in the last chapter, we looked at character strings as a third data type. Well, in this chapter, we introduce another data type that is known as a logical. And this is something that can be either a true or a false. And we will start out by setting the object x equal to true. True has to be in all caps, and there it is. So you can see in the upper right, x has been set to true. And if I were to type x, it would say that is a vector of length 1 that contains true. Now, true is a reserved word. We don't want to say something like true equals 17. R will be quite upset over that and say, I'm not going to let you overwrite true with 17. It will complain. Now, there is an abbreviation here that I could have used that's a little bit dangerous, and I suggest you not use it, even though I'll use it a little bit here in this particular chapter. I could have set x equal to just capital T, and when I do that, you can see up here, x still has the value true. So capital T is a legitimate abbreviation, but there's a problem. I can take capital T, set it equal to 17, and you can see T is now equal to 17. That's not so good, because if I then set x equal to T, I've got a 17 rather than a true. So even though I recommend that you don't use the abbreviation T, I thought I'd let you know that it's out there and dangerous. So I am at this point going to remove T from the mix and set my vector x here to true, false, true, false, true, false. So in this case, x is a vector of length 6. It consists of logicals, and you can see that it's true, false, true, false, true, false. The next question might be, what is the mode of the vector x? And in this case, it's returned as a logical. So this is the new thing that can be put into either a vector or a matrix or an array. You can put logical values in there. Like any other vector, you can ask for its length, and it'll tell you there are 6 elements. Here are 2 nice functions. The first is any. And what any does is it asks the question, are there any true elements in x? And the answer is yes, there are true elements in x. There's another one here which is called all, and this asks the question, are all of the elements in x true? And the answer to that is false. At this point, we're going to look at a number of operations. The first one is the not operation. And all this does is it changes true to false and false to true. So if I say what is not x, it is false, true, false, true, false, true. At this point, I'm going to take a look at x one more time, and I'm going to set a vector y. And again, just to save a little bit of typing, I'm just going to say that's true, 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 false, false, false. In any coding that you do, I strongly recommend that you write out the words true and false in all capital letters. But in any case, we now have a vector y, which looks like this. The reason I want to have two 6-element vectors here is there are certain vectorized operations, and this one right here is the vectorized AND operation. It is done with an ampersand, which is Shift 7 on the keyboard. Notice that when you do this, if you look at x and y, if both of the values are true, then the AND of the two is set to true. So in this case, and in the third position, we have two trues, and that's where we get a true. Everywhere else, for example, when we have false and true, that's a false. False and false gives us a false, and a true and false gives us a false. So the only time an AND will return a true value is when both of the arguments are true. So that's the AND operation. There is also a vectorized OR operation, and this is read X or Y. And when I say vectorized, that means it'll go through one by one, looking at the values and comparing them. And in this case, you get a whole lot more trues. In fact, it will return a true if both of the values X and Y are a true, but it'll also return a true if only one of them is a true. So the false true here evaluates to true. And likewise as you go, the only two times this will return a false is when the two arguments, this one here for x and this one here for y, are both false. So that is the vectorized AND and the vectorized OR. Here is a mistake that comes up from time to time. What is this thing? That right there is a non-vectorized and that comes back with a true. All that did was it looked at the first element of x, which is a true, and the first element of y, which is also a true, and it returns true and it stops. Now this operates rather quickly because it does something that computer scientists refer to as short circuit evaluation. If x had evaluated to a false, it wouldn't even check the logical status of y. It would just return a false right away. So that speeds things up. But remember, that one is not vectorized. Likewise, there is the non-vectorized version of OR, and this one also goes to x, sees a true, and at that point with the short circuit evaluation it stops, but you could also say if it sees another true it will still return a true, but all it needs to do is see one true and it is done. You print out x real quick here. What do you think the sum of x would look like? What happens when you add up a bunch of trues and falses? Well, the sum only makes sense when you have numeric or maybe complex variables. It doesn't make sense to add character strings, for example, and it really doesn't make sense to add up logicals. But R does something in this case, and what it does is it does some automatic coercion. What it does is it changes all the trues to ones and all the falses to zeros. So in this particular case, it'll come back with a 3. You can also try something like this. I'll let you try to guess what that would return. In this case, there are a bunch of ones and zeros. It'll treat the trues as ones and the falses as zeros. So this will be 3/6 or 1/2. And that's basically the outline of some of the operations that you can do on logical values. Ands, ors, and nots are primarily what you have. Finally, the last thing is kind of a review of the data structures that we've done so far. I'm going to use the class function here. This is the lowest on the kind of complexity scale of everything that's out there. That's null. That is going to be a vector or an object with nothing in it. So if I ask what class that is, it will say null. The next up the food chain in terms of amount of information stored will be a logical, and I'll just choose true here as my logical that I want to look at. And if you ask what class that is, it'll tell you that that is a logical. Now there's one that we haven't hit quite yet, but when you attach the letter capital L onto a variable, what it will do is it will treat it as an integer. So this will not be treated internally as 3.000 floating point. It'll be treated as the integer 3, and it will force that. And in this case, that will tell you that this is an integer. Whereas, if you were to just say class 3, now I'm not putting the L there, which forces it to be an integer. This will be treated as a floating point, and in this case, class returns numeric. Next up the food chain are the complex variables, so I'll put in a 3 plus 4i. And in that case, it returns and says that that is of type complex. So again, look at all the data types we have, and there's still one more that is further up. If you say class and you put in any string you want, yak is fine, and that's character. So what I've listed, let me count them here, 1, 2, 3, 4, 5, 6. There are 6 different data types here. The first being null, which is nothing. It is like an empty vector or empty element. The second up is a logical, which is either true or false, and that only takes, of course, 1 bit to store. In terms of storage, the next thing up is an integer value, like 3. It takes still more storage to handle the floating point 3, and that's called numeric. The next up is complex, where you're actually storing the 2 floating points 3 and 4. So that takes still more storage. And finally, taking the most storage of all is a character string. 6 different classes, and that takes care of logical elements.